Hi, I'm Dennis, and I'm going to talk about our method to improve performance on multi-agent coordination tasks by using joint attention. So one of the main challenges in multi-agent RL is that it can be very expensive. A lot of recent approaches like MADDPG and QMix use decentralized execution, where each agent has a separate fixed-sized action space, and this prevents the exponential growth of the action space as additional agents are added. But now, as the agent policies update, the environment appears non-stationary to each individual agent. To address this, it's common to add a centralized critic that looks at all of the actions, but unfortunately, the space of the inputs to the critic also grows exponentially with the number of agents. To address this problem, we drew some inspiration from humans. So when humans coordinate on a task, they don't need to consider all of the possible objects and actions their partners could take because they have the ability to infer and direct what other humans are paying attention to. This ability is called joint attention, and it's an important milestone in the development of human infants. So we thought this could be a useful inductive bias to add to an RL agent as well. The hypothesis is that agents can learn to filter out most of the environment and only act on the relevant objects. So even though they learn and act independently, because of this bias, they don't need to explore the entire exponential action space independently. So this is an example of the architecture we use for our agents. The important step is highlighted in red. So we generate a bunch of weights over the input image and use a softmax layer to force the agent to attend to only a few objects. This is equivalent to the dot product attention used in transformers, but over the pixels or objects in an image rather than text. We then compare the attention maps using Jensen-Shannon divergence with more similar maps between agents resulting in more reward. The idea behind adjusting the reward rather than changing the loss function directly is that the agents can then trade off a more accurate match now in order to learn to help the team improve coordination later. So for example, it can move its focus onto a different area and take a step in that direction in order to draw the attention of the teammates to that area. For the environments, we use a couple of grid worlds with coordination tasks, such as meeting up at the same location, gathering items of the same color, or collectively hunting a high reward stag rather than independently gathering low reward berries. Our experimental results show that restricting the agent's attention to a few objects improves performance, and encouraging those attention maps to match improves the results even further. So here we can see the attention maps on the stag hunt task, where the movement of the agents is on the left, the attention of the red and blue agents are on the middle and right. The larger circles show more recent attention, while darker circles show stronger attention. And you can see that in the joint attention agent on top, both agents focus on the stag in the bottom right corner, while in the baseline agents below, the agents move to collect their own berries and do not coordinate. Another interesting result is that matching attention with an expert can improve learning. So we have a complex multi-step task that each agent must complete independently. But in this situation, focusing on what the expert focuses on can improve learning speed, since it again filters out the irrelevant parts of the environment. So yeah, we provide a new attention architecture and attention matching incentive. In humans, joint attention helps with coordination and learning from experts, and we show that in our method, it helps agents with providing the same benefits. We're still missing the other part of joint attention, which is the ability to direct attention explicitly. And we think that this method in general could be interesting to apply to human AI interaction as well. So thank you for listening.